Thank you, everyone, for coming here. First, I want to ask a couple questions about you. I want to get to know you a little bit. Who here uses Spring? All right, pretty much everyone. All right, no one's like, I never heard about this Spring thing. Let me see what this is. Okay. How many of you who are using Spring are using Kotlin with Spring? A few. Okay. That's fine. I am going to be showing Kotlin code, but the kind of whole point about this is going to be that it's easy to understand. So hopefully I can make that case to you as we go on. A little bit about me. My name is John Burns. I'm a platform engineer at Grubhub. I'm also the maintainer of the KT-Link Gradle project, which is a Gradle plugin that links your Kotlin code. And I'm also the maintainer of the Spring Funk project, which is something that I'll be talking about in this talk a little bit at the end. You can find me on GitHub. You can find me on Fediverse/Mastodon if you want to reach out. Otherwise, come talk to me after this talk, and we can connect on LinkedIn if that's your preference. So like I mentioned, I work at Grubhub, and this is usually the part of the talk where I talk about our open roles. However, in this particular case, unfortunately, we did have some layoffs last week, and we don't have any open roles. However, if you are a hiring manager and want to pick up some really top-tier engineering talent who know how to build microservices that can scale, run in hot data centers, SREs, that kind of thing, some really good talent on the market now. And if you're looking for that, come talk to me, and I can point you in the direction of some of my colleagues who are looking. All right, that sad business out of the way. In the beginning of Spring, there was XML, right? Spring came out over 20 years ago now, and when it did, the main way that we configured Spring was through XML. Now, the organizers of the conference told me I can't actually show that to you. It's too obscene. We don't want to scar the minds of the younger developers in the room who maybe haven't seen this before. Okay, but suffice to say, nobody liked this, right? This was painful. So about 10 years ago, we got Spring Boot. Now, Spring Boot was designed specifically to support the use case of embedded servlet containers, right? You are shipping an application, and the servlet container, like Jetty, Tomcat, whatever you want to use, is embedded in your application. Now, that might seem obvious now, but to those of us who were using Spring before this, the way it used to work, you would deploy your application to a web container, like JBoss, WebSphere, that kind of thing. I know that's still done to this day, and that's kind of the Java EE, Jakarta EE way of handling things. But I think it's a lot less common now, right? Around that time, 10 years ago, is when microservices were really taking off, right? And with a microservice, everything should be independent. And each independent service has to have that servlet container, so it's embedded. So that was the main thing Spring Boot brought to the table, was we will let you do this very easily. It's going to basically just happen for you automatically. But the other thing that it did is change the way we configure Spring applications. Instead of piles of XML that kind of like live off to the side, and it's really hard to remember where the XML associates with the code and all of that kind of thing, now you're sprinkling annotations throughout your code that tell Spring what it needs to do with your code. And this was a huge step forward and made it a lot easier to use Spring. So good, right? Great. Everybody loves Spring, and no one ever has any problem with it, right? Okay, no. Well, yeah, so there's still some problems. So first of all, yes, the good thing is we have no XML. Although I will say I do think XML is a little bit unfairly maligned as a technology, but that's okay. No one likes writing XML for their code, like the configuration of their code. How about that, right? So with the annotations, that wiring lives closer to your code. It's a lot less boilerplate. So that's all good, but let's talk about the bad things. What problems do we still have to solve? The learning curve is steep. I see this all the time when a new developer, especially at the lower levels of their career, join our organization, which is heavily Spring Boot based, and they have not used Spring before. Maybe they're coming from another language, or maybe they're just coming from another framework or ecosystem within Java. But that learning curve can be steep. These annotations are, until you know the actual like idioms and conventions of Spring, it seems like nonsense. And discovering how they work is hard too. Documentation for Spring is very good, definitely. But if you're in the code, right, like working actually in your workflow, control clicking, or if you're using Apple, whatever that little symbol is, yeah, the annotation doesn't really tell you a lot. It brings you to an annotation declaration. A lot of good that does you, right? It's really hard to figure out what it does just by looking at that code. Another thing is performance. So in order to make all of these annotations magically work, Spring is doing a lot of reflection, and it's actually loading your entire class path multiple times at startup in order to properly evaluate conditional expressions and things like that. So you take a huge startup performance hit. Now when Spring Boot came out, that's not a big deal, right? We're like, these are long-lived servers. If it takes a couple minutes to boot up, we don't really care, right? But today, that's starting to become a problem, right? We want auto-scaling services that can come, new instances can come up quickly, right? We're running Lambdas, maybe, that get torn down and refreshed very often, right? So that startup cost is starting to become a bottleneck. And finally, the code can become structureless, right? With these annotations that are so magical that just scan your packages and just wire everything up, it's really easy to end up with a big ball of mud where anything can call anything, you get circular dependencies. If you have a lot of rigor, then you can avoid that, and more power to you. But with a larger organization, with a lot of developers coming in with their own conventions around how they do things, it can quickly devolve. There is a framework that's gotten popular the last couple of years called Modulith, Spring Modulith, that helps with this particular problem of structure. It kind of gives you some guardrails on like how you structure your code, how you structure your packages, and it will actually check those things at build time. So that's great. And actually, everything I talk about today is compatible with using Modulith. But I think Modulith only addresses that specific problem of structure, and it doesn't address necessarily these two other issues. So first, I want to talk about the learning curve. Now, what could we do to make the learning curve less in Spring Boot? Well, one thing is we can use less of the magic stuff, right? Some of this stuff is so magical, you don't even know it's happening. And if you don't know what's happening, how can you learn about how it works, right? So one thing you can do is decompose some of the magic. Be more explicit about your configuration. So here's a Spring Boot application that is not using component scan. We are not going to scan for classes annotated as at repository or at component or at service. We are going to explicitly tell our Spring configuration class which beans to create. So this is a lot more explicit, and this works really well with Modulith because then you can create multiple configuration classes that each are responsible for one vertical slice of your application, right? And it gives your application structure. But you might notice that this code is going off the bottom of the screen here. That is by design because I wanted to show you that this is a lot of extra boilerplate, right? So it does make it easier to reason about, but we still have a lot of annotations that are doing a lot of magic, just less, and we're increasing the boilerplate. But I wanted to show this because it kind of sets the stage of like where we need to be for the next thing that I'm going to show you. But let's talk about the remaining issues before we go into the solutions. We're still like I said, we're still using auto configuration, right? So even though we are not doing a component scan, I will actually call this out specifically. So the Spring Boot application annotation that is very popular that you start your application with is actually a meta annotation. It is the Spring Boot configuration, enable auto configuration, and component scan. So what I've done in this example is I've just decomposed that into the 3 and then removed the component scan. So I have Spring Boot configuration and enable auto configuration still, and enable WebMVC to make it so I can serve up an API. So we're still using auto configuration, and despite so it's not just that auto configuration is magical and hard to follow. It's also that that's where a lot of that performance problem is, because the auto configuration process is the thing that's doing all of this reflection and class path loading and things like that. We're still using these annotations, as I mentioned, that can be hard to learn and get context around. And as I mentioned, we're getting a lot more boilerplate. So it's been 10 years since Spring Boot came out, and now we have Spring Boot 3. And there has quietly been a new paradigm introduced into Spring Boot called programmatic configuration. Now, I'm calling this functional Spring, but the Spring team internally, I think they refer to it as programmatic configuration. I think functional just rolls off the tongue more. And you might see why I particularly use that term in a minute. So programmatic configuration actually kind of flies in the face of what Spring Boot was originally, which was, we're going to do all the things for you automatically. Programmatic configuration says you have to actually tell it what to do. It's explicit. But it provides a basis for a new level of abstraction over that I think strikes a better balance between like reducing boilerplate but still making the code easy to understand. So where we'll end up is still more boilerplate than the fully annotation-based stuff, but it's going to be much easier to reason about. Another advantage of programmatic configuration is that tests are very fast because you don't have to test your configuration code with @springboot_test and spin up the whole application every time. You can use these functional interfaces that are actually in Spring and just new up an empty context and pass it in, and then after the function is called, you can just like inspect that context object for like which beans have been created and things like that, and it's very quickly. And also, the actual app startup itself is very fast. So, to showcase all of this, there was a project started, I think about 8 years ago now, called Spring Foo. And it was started by someone on the Spring team named Sebastian Deluse, my personal developer hero and idol, okay? Shout out to Sebastian, he does a lot of great work. One of the things that he did was create this experimental project called Spring Foo. And in it, he said, what if we took this programmatic configuration concept and pushed it as far as we could go? Completely get rid of all auto configuration, rewrite all of the Spring Boot auto configurations you get out of the box as these functional configuration implementations. So it makes heavy use of this new interface in Spring called the Application Context Initializer. And that is, it's just an interface, but it's something that you can wire up with the Spring.Factories meta in file to run at startup. And it's a purely functional way of doing the configuration. Basically, the interface takes the context object as a parameter, and then you just do whatever you want to it within there. Spring Foo also, on top of that, provided what we call DSLs around those initializers for configuring them. Now, these are not really DSLs. What they are builder patterns. Spring Foo supported both Java and Kotlin, so there was Kofu and Jafu. Jafu is the Java version, Kofu is the Kotlin version. In the Java version, it's builders. Your typical Java builders, you construct your initializers, basically, with various configurations and settings before they actually run. In Kotlin, we have a lot of language features that make doing that kind of code a lot more expressive. And we call them DSLs in the Kotlin ecosystem. They're not, like I said, they're not true DSLs. What they are Kotlin fancy builder patterns. But I'm just going to call them DSLs from now on, because the end effect is that it does approach a DSL-like thing. So the downside of Spring Foo is that it required you to go all in. You could not have like an existing Spring Boot app with all the annotations and just start sprinkling in elements of Spring Foo. The way that you spun up a Spring Foo application involved special code in your main method itself to how it gets bootstrapped up. So that made it kind of a non-starter for an enterprise that wants to start using this technology, right? Or in any kind of existing thing that wants to start using this technology. But it was a very interesting like proof of concept that all of this stuff is possible. One of the main motivations of Spring Foo was trying to get Spring to run on AOT, right? GraalVM. because of all the reflection Spring Boot does, it couldn't at that time run on GraalVM. So this was a possible path to supporting GraalVM. But because it would require you to basically rewrite all of your Spring configuration code, it's not a good path to GraalVM. So what happened was that Sebastian was basically reassigned to take a different approach to GraalVM support, which involved providing those compiler hints to the AOT for Spring Boot so that it could do what it needs to do with reflection. And then no one has to rewrite their stuff. You can just run your Spring Boot app on AOT now, and it's great. And that project all went very well, but what it meant was that the Spring Foo project was kind of abandoned at that point. Now, some of it did get contributed to Core Spring. So there's two particular elements that did make their way from Spring Foo into the core of Spring, actually as of Spring 5 and Spring Boot 2. So first I'm going to talk through those two, because those two are there in Spring. If you're writing Spring Boot, you can use those today. And then I'm going to go through what else can we do beyond this. How can we take this concept further? So first is the Beans DSL. Has anyone in here seen this before? One person. OK, cool. Let's talk later. So this is only available in Kotlin because some of the syntax that it requires is just you can only do it with Kotlin. The Java equivalent is so messy, it's just not even worth it. OK, so this is available in Kotlin. It comes from Spring Core. There's not a separate module you need to pull in. It's just right in Spring Core. But it allows you to programmatically define the beans of your application, just like how you see here. Now, there's a lot of different variations of the method, like overloads for different use cases and everything like that. So I can't show them all here, but here's just some examples. So a simple case is I want to declare a bean. I give it a type, the generic type, and Kotlin uses inline reified generics to actually get the class reference of that type and basically pull the bean or declare the bean in the context using its default constructor and all of that kind of stuff. The next example shows you how we really start to see the advantages of this over the @bean method on a configuration class for the things you need to inject into that bean. If your bean takes a dependency, right? Remember that the traditional way of doing an @bean method where you're explicitly saying, I want to declare this bean, you have to list every single parameter in the function, right? And then pass it into the constructor of the bean. It's very painful, and that's why people just say, whatever, I'll just put @service on my class and let it get scanned, right? In this case, there's some nice helper functions in the DSL where if I'm invoking a constructor, like in this lambda here, on the second bean, I'm invoking this constructor, and it has an argument. I just put ref, and I just let, basically the compiler figures it out. This is not using anything frameworky. This is literally just using the Kotlin language features that exist. Inline reified generic functions, basically, and extension functions are the main things that it's using under the hood. So this is not any kind of special Spring thing, really. It's just a simple method written in Spring that translates to basically bean factory.get bean with the required type, which is inferred as the class reference that it passes in to get the bean of that type. And then on the last bean here, you see, well, what if we want to call our bean a certain name and we want to inject in a bean? We have multiple beans of that type. We want to pick which one we want to inject in, right? Qualifier is what it's normally called in Spring. It's just a string parameter that you can pass in, right? So this is a lot less boilerplate to do the same thing, but it's still, you can still read it and see what's happening, right? You can read it just as easily as the explicit bean configuration class, but it's way less boilerplate. And all of these things are just methods you can click on and go, dig in and see the code and see what's actually happening under the hood. And again, another mention, tests for this, extremely fast. The beans object that's created here, we see val beans at the top, is an object. It is actually an initializer, an application context initializer itself. So if you just take that beans object and call dot initialize on it and pass in an empty generic application context or something like that, then it will do its thing, declare the beans, and you can check that those beans exist, or those bean definitions are in the context. You're talking milliseconds for a test. Okay, The next DSL is the router DSL. So this is a replacement for declaring like REST controllers and that kind of thing. So basically what you do is you declare a function as a value, and it's a Kotlin thing. So basically we say, I want to declare my routes. You can inject in, so if you have like a service layer that you need to have business logic on that you need to invoke from your controllers, right? You can pass that in as a parameter to the method, and then you say equals router, now you're in the DSL. So you can declare your routes by just using the HTTP verb. That's just a method call. The path, and then that can include like path parameters and all of that kind of stuff that you're used to. And then you tell it basically the lambda or method reference to call when that route is hit. The only requirement for this is that the method that it's calling has to have a particular signature. It has to take a server request object and return a server response object, which are just abstractions over like request entity and response entity. I'm going to show some more examples of this a little bit later. But I can't stress it enough, this is very easy to test, right? You don't need to worry about like mock MVC and that kind of stuff, because I mean, you'll probably have your one like integration test where you are actually spinning up like a test REST template or whatever and hitting all of your endpoints. But to test the logic of it, like, oh, in this case we get a 404, in this case we get a 200, all of those like different like non-happy path tests are very easy to do because you just test that function, right? The function that takes a server request and returns a server response. And you can just construct the request and then see what response comes back, right? So you can test, oh, status code equals 404, whatever, right? Like that information is all available. You don't have to worry about configuring mock MVC, controller advice, all of that kind of stuff. So it's a lot more like functional in the terms of functional programming, where it's a pure function that takes an input and gives you a specific output. So putting that all together, this is what a functional Spring application can look like today using just the pieces that are available to you in Spring Boot right now. The one caveat here is that you'll notice that our application class implements the application context initializer interface. And when you do that, in order for Spring to see it, you have to add it to the spring.factories file in your meta-inf folder under resources. So that's kind of annoying, right? But that's like a one-time thing. You have to do it once, and then it's done. So this is going to get a little bit better in Spring 7. So this is not yet merged, but what I'm about to talk about. Yeah, you have a quick question? Oh, okay. All right, so coming in Spring 7, this PR is not merged yet, but it looks like this is going to get a little bit easier. There's going to be a new thing called a bean registrar DSL, which gives you access to the bean declaration DSL in a way where it's more seamlessly integrating with like a regular Spring Boot app. Right? So you can just do this at import, point at the bean registrar, and the bean registrar looks like that at the bottom there. And then it's very similar to the beans DSL that we saw before. So this will get easier in Spring Boot 7. Quick question? I'm getting there. Yep. But I'm just right now covering what you can do right now today. And then I'll talk about what we can do, how we can go further. Okay, so this is coming soon. So it's a little bit nicer, right? But okay, so remaining issues. Still need auto configuration, right? Okay, so we still have that startup cost. It's a bit less. We're able to make things a little bit more efficient because we're using less of it. But it's still there, right? And this is also not extensible. So how many of you, and I'm not expecting this to be a high number, but how many of you write code that is a library that uses things like, declares like Spring Boot auto configurations or something like that, that you deliver to other developers to use as a library or a framework? Okay, yeah, there's a handful. So if you wanted to improve the developer experience of your library or framework to do something like this, there's nothing really for you. Like you can write your own application context initializers, like great, but that's like hard coded, right? Like how do you make that configurable? How do you give your users access to like declare their, like something similar to like declare their beans and things like that, right? Nothing really there for that. So this is where the Spring Funk project comes into play that I mentioned earlier in the talk. The Spring Funk project is a continuation of the Spring Foo project. And what I've done is I've basically taken all of the initializer code that Spring Foo had and bring it over to my project. But I've also mixed in some ideas that I've had because all of this functional stuff we have implemented at Grubhub. Right? Spring Foo project has been around 8 years, like I said, right? But it never really went anywhere. And I was waiting and waiting and waiting and waiting for it to go somewhere. And finally I said, I can't wait for this anymore. I'm just going to just start doing this stuff in our framework. We have our own framework on top of Spring Boot. And through doing that, I learned a lot about, first of all, how it works. But second of all, like how it could be better and how it could be made to be more practical in the enterprise for gradual adoption and things like that. So I took all of those learnings combined with what Sebastian had to create Spring Funk project. Now my dream is that this project ceases to exist one day because all this stuff is handled in Spring Core. So, you know, it's not like I'm trying to like have this new project that's gonna be this whole big thing. But my goal here is to popularize these functional approaches so that there's more interest in adding these things to Spring. But it is fully usable. This stuff, like I said, we've been doing this stuff in production at my company. We have like 200 microservices for years. So this is what the application can look like with Spring Funk. So you'll notice now we have an application class that implements the Spring Funk application interface. And then we have the next line is the entry point into the Funk DSL. The DSL is basically a container for any number of other DSLs. So the first one you see here is beans. So this, once you're in this beans like block here, this is just the Spring Beans DSL that comes out of the box in Spring. I'm just wrapping it. WebMVC. Now instead of an @enable WebMVC annotation, we're actually explicitly saying, okay, let's do some WebMVC stuff. First of all, we want to enable WebMVC. Let's pick our servlet container, Jetty. One of the interesting things about Spring Boot is that when you run a Spring Boot application, are you getting Jetty or are you getting Tomcat? How do you know which one you're getting? Anyone know? Shout it out. Yeah, it's whichever is on the class path, right? And if there's multiple, then I don't know, like maybe Spring picks Tomcat by default, I'm not sure. But it's very implicit, right? This makes it a little bit more explicit. Not a lot of boilerplate, like, right? Like keep it to a minimum. The words Jetty and some parentheses, not too much to ask, right? But now at least we know what's happening. We can see, oh yes, we're using Jetty here. And now we go right into the router DSL, right? So I can declare our routes here, everything like that. This is, again, just the router DSL that comes from Spring. It's just being wrapped. So Spring Funk also establishes a pattern of how to write your own DSLs and integrate them into this paradigm. So if you go to the repo, and there'll be a link at the end, you'll see that, like as an example, I created a DSL that makes it easy to wire up various AWS clients like S3 client, SNS client, SQS client, like those AWS SDK clients. We use AWS, so I just use that as an example, and how you can make a DSL for like making that easier. So this hopefully looks cool and piques your interest, but I think that like it's really nice to be able to see it in action. So the next thing I'm going to do is a demo. So give me 1 second to switch over to my IDE here. But if anyone has any quick questions, I can answer them as I do this. So. Uh-oh, of course now this is not working. What happened to my... I've lost my other screen. Sorry, 1 second. There it is. Okay, we are good here. Okay. Maybe we can do, how is that? Is that big enough? Oh, what just happened? Why did you do that? Okay, well maybe I will. Oh, I know why I did that. Oh my gosh. Okay. Okay. All right. Is this big enough? This? Okay. Q and the Alt 1. Okay. Okay, so here's my project. This is just a basic Spring Boot application. We have a application class, we have a controller class, we have a service class for some business logic. We're wiring in the configuration properties, that's type safe configuration in Spring Boot. All right. All this application is doing, and we have our main, right? All this application is doing is calling this hi with a name parameter, and then invoking the service method that says say hi. We're gonna use configuration to say what our greeting should be, and just return with that and the name that was passed in. Our integration test is just going to configure that we want to say, the way we want to say hi is with the word hello. And so we're just going to call this, we're going to say, we want it to say hello to me. So we're going to expect that it comes back okay, and then we assert that the response is going to be hello, John. Okay, oh, I had to download some dependencies. Why? I just built this, okay. All right, so here we go. So that ran. Ran in 786 milliseconds, still pretty fast, right? Because this is a simple application. I do want to point out, if you're particularly interested in the performance aspect of everything, I'm not the best person to show that to you. What you should do is find Sebastian Delius's talk he did recently. I don't remember at what conference, but he has one out there, and I think I have a link to it in the slides, which I'll share at the end, of a demo doing a Spring Boot app that starts up with purely functional stuff and GraalVM, I believe in 0.002 seconds. Right? It's pretty impressive. I'm not going to drill in as hard on the performance thing here. I'm more about the developer experience of using it. Right? So we have this test. And one thing I want to point out is that with Spring Foo in that project, you could not use that Spring Boot test. It was incompatible with the way that the application started up. So one of the innovations here with my Funk project is it will work with Spring Boot tests. So we're not going to touch this test at all. We'll just leave that here. Okay, so the first thing we want to do is take Spring Boot application and decompose this. So we need Spring Boot configuration and enable auto configuration. We'll eventually get rid of that, right? But for now, let's use that. So when we do that and try to run our test, what do you think is going to happen? What are we going to lose? .404 not found. We lost our controller, right? The controller is no longer wired up because it's not being component scanned in. So the way we solve that is by declaring it as a bean, right? So let's do that. We have beans. I'll declare a bean of my controller type. All right, and then remember, we need to have an initializer. So we do have to do this. This is the boilerplate that we do have for now. We need an application context initializer. I generally, there's different interfaces you can use. I generally just use generic application context. That's most of the time what your context is. All right, and so then when you do this, we can implement this. And then within the initializer, beans itself is an initializer, so we can just delegate to it. Initialize with the application context that we have here. Okay, so now I'll run my test again. Anyone want to you can just shout out what you think is going to happen? We are missing. Oh, yep, we're still 404 because, as I said, we need to add the application context initializer to the factories file. This is the way Spring Boot discovers it because we're not doing like the full auto configuration class path scanning thing. So this is Spring framework dot, where is it? There it is. Application context initializer, and then we just put our com.example. Our application is an initializer, so we can do that. All right, let's run it. Now how will it fail? It will fail. Okay, failed to load application context. This is one of those things, right? Like if you're new to Spring and you see this and you're just, what is going on, right? But I've been doing this a while. I know what to look for. It is unsatisfied dependency, right? Okay, so we don't have, our controller's trying to spin up, but it's missing one of its dependencies, the service class, right? We're trying to inject that, but we never declared that as a bean. Okay, so we just add that. The feature one service. Run it. Okay, we're in a working state. Okay, so we've converted our beans. So now once we've done this, like we don't need this annotation anymore. So you'll notice here that like this, we start to see a separation here, right, between our business logic code and our actual configuration, right? Like you don't have Spring stuff sprinkled through all your application anymore. It's more contained. Like you have your Spring wiring, your configuration code, and then you have your code. And that line is blurred less. Okay, so we're in a working state. What's next? Well, let's get rid of our controller, right? Because we have router DSL. So let's say our routes are going to look like, well, remember our route uses the service as a dependency. So we'll inject that in here. And router. And wait, is this? Did that wrong. Okay, it's actually a function, not a val. Kotlin has top-level functions. That's what this is. You don't need a class to declare a function in Kotlin. So this is just declaring a function. It takes this parameter, and we can declare some routes. So what does our controller look like again? We're doing a get on hi/name. And then we want to call service.hello. All right, so here's the problem is that service.hello, this is a controller, right? It's just like returning a response entity. So we are going to need to define like a actual, like the right signature for this. So let's do our hello route, and it will take a request and its server request, and then it'll return a response. Server response. And all it's going to do, it also needs a reference to the service, right? So service, each one service. Okay, so all this is going to do is call service.sayHi with request.path variable, right, called name, and return that. And it needs to be a server response, so we'll just say it's an OK response, right, because that's what's supposed to return with this body. Going off the edge there, okay. All right, so once we've done that, then this can just be a call to the hello route, passing in the service and the request. Okay, we don't need that. All right, so here's our routes. How do we actually register the routes? We actually just can declare it as a bean. So it doesn't have to be like a separate initializer or anything like that. We declare that as a bean. Once that's all there, I can run this. What's going to happen? It works. A little bit surprised it worked, honestly, because I thought it would be a conflict. But the thing is that now that we have all of that, we actually don't need this controller at all. Right? I rewrote this line of code, right, up in that other thing. So I can actually just delete this. Get rid of that. Which means I no longer need this bean. Okay. Let's make sure it still works. And I didn't do something terribly wrong. Yeah, it still works. Okay, there we go. Now, you might be saying, like, well, yeah, but I don't want to throw like all my stuff in like the main class, right? Correct. The interesting thing about this approach is that because these are all just like functions, when it comes time to start organizing your code, maybe slicing it into these like vertical slices that are in different packages or things like that, we no longer need like frameworky stuff to do that. Like we don't need to worry about like Spring slices, configuration classes that like only configure one slice, all that kind of stuff. At this point, we can just utilize our language features of Kotlin to do that for us. So we can just like the routes that are related to feature one and the route and the business logic and all that kind of stuff. We can just move that to a different file in a different place and have those functions defined there, and we just invoke it at this top level. I'll show an example of that in a little bit if we have time. But the one thing I want to get to first is getting rid of all of these annotations, right? So this what we have right here is pure Spring Boot, right? I haven't used any third-party libraries here. You can do this today in your application, and this all works. But the next thing I want to show is, all right, well, what more can we do? So I'm going to pull in my Spring Funk library. It's on Maven Central. I'll let Gradle refresh. Hopefully I don't regret that. Okay, so now that we have that, we actually just change this initializer here to just make it a Spring Funk application. Now that's going to change the signature that we need to override. So I'll just let the IDE do that for me. And there's a little syntactical trick I can do to make this a little bit easier to read, is put an equal sign there. Now I can start doing something like this. Okay, so for beans, let's just, let's just copy paste that down in there. We want WebMVC, right? So let's do WebMVC, enable WebMVC. See how like the code completion, Kotlin has something that it does with DSLs where they're scoped. And so you see like this suggestion is yellow. That tells you that's part of the DSL. So it helps guide you like what can you actually do here at this part of the DSL. So we want to enable WebMVC. And we definitely want to use Jetty. And then let's do our routes. Now I'm going to have a, I think I might have a namespace issue here, but let's see. So routes is what I want here, the DSL routes. And I can do a router, and it's my routes function, I believe. Oh. It is, why am I? Oh, because that's a router. So I want to do, this is the trickiest part. Okay, so this is the signature of router. It takes a function that takes the bean supplier context, returns the router function. The router function itself is this routes. So I think it's supposed to be like this. It's, oh. Oh, okay. Not access routes because it's private. Oh, yep, this is, okay, because it is a name. So I'm gonna just call this my routes. It's seeing the wrong thing. Okay. And, oh my gosh. Okay, I can just do it like this. Here we go. I'm just gonna inline it. So then it's at that point it's this. Okay, there we go. Sorry about that. Okay, so then I don't actually need this bit anymore. Okay, so now we shouldn't need any of this, any of this, or this. Leave the configuration properties for now. And okay, I have one compile error. What's happening? Oh, I don't need this bean of routes declared anymore either because I'm using this DSL, which will do that for us under the hood. Okay, let's run it. And oh, we have an error, and it is no such bean of future one service. I think that's because this beans is okay. So just an import that shouldn't have been there. The wrong beans. Okay, that's just an artifact of the fact that I had it one way and I'm switching it to the other, and then I'm using the same names for stuff. Okay, and it worked. Okay, so the final thing is the final annotation we have in our application is this like configuration properties thing. There's an interesting thing about configuration properties is that they can't be updated at runtime unless you use a library called Spring Cloud. So with Spring Funk, I actually have like an alternative to that. So I have this thing called runtime config. Allows you to register a configuration class. The difference between this is that it will automatically support runtime updates, but Spring Cloud won't let you do that with an immutable data class. I like immutability. I'm functional programming nerd like that. So this one works a little bit differently. The only difference is that we have to inject it as a runtime config of that type and then call a getter. So it'll give us a different object if the actual environment properties change in our application. Okay, now run this. We're doing on time. Okay. All right, so there we go. So it works. Okay, so now we have an application that does not use any Spring annotations. So the whole point of this, well, this is here. We don't actually need it, but it can be useful for like declaring the prefix and to allow IntelliJ to know that it exists. But it's not actually needed. Okay, so there we go. So my whole point about all of this is that, is hopefully that it's like fairly easy to use. Like, I obviously, like, I know this stuff, and so I'm able to like do it quickly up here, right in front of you. And if you tried to do it, you'd be stumbling through it. Obviously, you've never seen it before, right? But hopefully the impression is that like this stuff, it can be simple, right? And once you like use it a little bit, it becomes very fast to develop new things. A lot less boilerplate to generate, and it allows you to like not have to learn like so many Spring idioms, because like if we once we start wanting to structure our code, we can do things like, like I was mentioning, if you wanted like to abstract away our routes, I'll just do a quick example of this because I don't have that much time left. But if say I create like a like my routes file where I want to like kind of just put this stuff in so that it's not so busy in the main thing. So if you look at this method here, this is a function that exists on the WebMVC DSL, and it's routes. Actually, so let's go inside one level. Routes DSL. Router is on the routes DSL object. Okay, so we can write an extension function here. So we can just say function routes DSL dot my routes. Okay, now what this is going to do is literally just be this. Paste this in here, it works, right? It compiles. And then in our main application class, we just call my routes. And now like we've abstracted that away. I always like to put my money where my mouth is. I'll run the test to show you that it still works. Still works. So this is how you can like, segment off, compartmentalize different parts of your code, abstract away some implementation details, and keep your code neat and clean and organized by just using language features. Now, I know that a lot of people in this room said they were not using Kotlin, so this might not seem so familiar to you yet. But trust me when I say that learning Kotlin as a language is a more transferable skill than learning like Spring annotation stuff, right? Like if you're gonna learn one of those two things, Kotlin could possibly be used in other places, and like this Spring annotation stuff is only used in Spring, right? That's my pitch on that. If you haven't used Kotlin yet, though, I do recommend you check it out. But the important thing is that like when you hire people in your organization too, more and more people are starting to have Kotlin experience. So if you show them this code with this extension function, they might actually understand it right away. Oh, I've seen this before. Now, granted, Spring more popular than Kotlin currently. I'm not like, I have no illusions about that. But, this I believe is actually the future of Spring. That's my pitch to you. Is that it's going to be interesting to see how do we actually surface all of this stuff in a consistent way throughout Spring. But there's definitely interest from the Spring team on making these like APIs more prominent in the Spring ecosystem. Like I said, in Spring Boot 7, they're adding some additional things to make it easier to do. So if it's something that you're interested in, you should definitely try it out and like give feedback to the Spring team because they're looking for it. For the people who are using this stuff, feedback on how it works, how it doesn't, where the rough points are. And I have a few minutes left for some questions. If we don't get to a question, then come find me in the hallway afterwards. But the last thing I want to do before going over to questions is the last slide. No, this is not my actual slide. Here we go. Okay, I have these resources, the Spring docs for these APIs, the Spring Foo project, the original one, the Spring Funk project. Not everything's been ported over from Foo to Funk, so if you like this stuff and want to help me out and port some of that stuff with me, I'm always looking for helpers. And then that Sebastian Delu's demo where he demonstrates the performance is up here too. If you want to get to that slide so you can click on those links, go here. So start at this link, go to my slides, then you can go to the that slide where all of those resources are, and here's where you can find me. So thank you all, because I know you have so many choices of which talks you can attend at this great conference, and it really means a lot to me that you came to see me rant about this stuff that I nerd out on all the time for an hour, so thank you all. All right, we have like 5 minutes for questions. Yeah.
I know that you removed the annotations there, but something is within the DSL somewhere. It's kind of saying, hey, or it's just implementing the interface that it wants instead of utilizing that annotation.
Yes. So the question was like, you've removed those annotations, but for the DSL, you still have to like implement the interface that it demands. Is that interesting?
That's probably the part that I was missing out.
Oh, right. Yeah, I know. I'm sorry. My pace is pretty fast. Yeah, that's basically the trade-off you're making, right? You're saying, instead of my hook into the framework being this annotation, it is an interface that I'm implementing, right? But that's not really the way it should be, right? Like, that's the lower level API, right? This interface thing. My pitch is that the developer developing a service should not have to be dealing with these interfaces directly. It should be exposed to them through a better way. So like there are a bunch of functional interfaces within Spring. Application Context Initializer, that bean registrar DSL is another one that's getting added. There are more, right? And so I don't want like Spring Boot developers to have to know like these 20 different like interfaces they may implement, right? That's already a thing in Spring, right? Like your configuration class can also implement some other random interface and then you can do this other thing, right? Like bean customizer or whatever, right? What I want is a single point of entry to say, like with Spring Funk, there's one interface you implement, the Spring Funk interface, and that is your entry point to everything else. After that, it's just methods on the DSL, right?
So, well, I know that you didn't add something like a data source, right?
Right.
So, the Spring is probably simplifying that more than anybody else. Give me your library, let's say it's relations.
Yeah.
Database, give me that library, give me a few properties, and we're off and running. I've done everything behind the scenes. How?
Yeah, so the question was about, like, I didn't show like hooking up to a database and all that kind of stuff in my demo, right? And so like Spring does a lot for you there, and how would that work here? And the answer to that would be, well, under the hood of Spring Boot right now, there's auto configurations doing all of that work, right? That code in auto configuration could be switched over to initializers. And if it was, then the way you hook into it, it could be completely driven off of those properties you mentioned. Like, we have features that we've written with initializers where all it does is read the environment properties and do the same thing the auto configuration would have done, but just in a programmatic way under the hood. To the end user, it's exactly the same. That can be done, but the other thing that you can do is then you can also provide a DSL that says, I want to declare, I want my database connection, like I want the my repository like bean to be called a certain name or whatever, like a qualifier or whatever. Like if you want to customize it, you can use that, you can wrap that initializer in a DSL to make it more customizable for the end user and expose those things in a type-safe functional way rather than like everything being in configuration. So I know this is like abstract, but basically my pitch there is that there are some things that make sense in like properties files, right, or your YAML or whatever it is. Things that might change from environment to environment to environment. Things that are always the same in every environment. Actually, the properties file is not the best place for it. It's not really type safe. Like some tooling exists to like make sure you don't like use a property that doesn't exist, but it's not type safe, and it's limited. It can only be like primitive values that you put in there, right? Like if you need a class reference, you can't just like put that in the properties, right? It's like a string, right? So that kind of configuration actually lends itself to be more code-based, like through like one of these DSLs. You can put in as part of the DSL like API a class reference to say I want to spin up a thing and it's going to use like this class as its delegate or whatever. You can do more complex things with that. And if it doesn't change from environment to environment to environment, it should be a code change when you change it. Things that are in your properties file are things that you change at runtime, right? Like, oh, in pre-prod it's this, the password is this, and in prod the password is that. That makes sense to be in a properties file. But the existence that we have 3 database like connection pools declared, right? And one of them has a size of 2, and one of them has a size of 10. Like that, you probably want static across every environment. So you can get the benefits of the type safety with a DSL, and you're not really losing much because it's not like you would have changed that between environments anyway, because then you wouldn't have like valid tests and like you wouldn't know if it actually worked when you went to production and things like that. So that's a little bit more of a controversial hot take, I think. Fair enough. But that's my vision for like how it would work. It's like, yes, you can deliver the exact same experience with an initializer if that's what you want. You don't have to do like these other functional DSLs around it. It can just be doing the same thing, but it performs way better because it's not auto configuration. That's what most of Spring Foo is, honestly. Sorry, I rambled on that one. Any other questions?
I did have one. Was there? So you're saying there's if you go the initializer rather than the increase in the startup.
Initializers are faster than auto configurations. It'll make your startup like take less time. They don't, because you're not using any reflection. It's just like you're getting a reference to a context object, and you're just saying register bean, like do whatever, add listener. So there's none of that reflection happening. So they're much faster. Yeah, thank you for coming.